In this video, we're going to trace the algorithm of converting from infix into postfix notation. So recall that infix notation is the notation we as humans are all used to. It's an operand on the left, an operator in the middle, and another operand on the right. So for example, 4 plus 3. This is the style that's easiest for people to interpret and evaluate, but not computers. So computers find it easiest to evaluate postfix notation. So that's why we want to be able to convert from infix, which is easiest for people, into postfix, which is easier for a computer. With infix notation, we need to worry about things like parentheses and rules of precedence and kind of all of those rules that we've all learned and how to evaluate mathematical expressions. But with postfix expressions, we don't have any of those rules. You kind of just evaluate things as they come, and you don't have to worry about precedence. There are no parentheses. So postfix is much easier for a computer to evaluate. And we're going to look at how you'd use a stack to evaluate a postfix expression in the next video. But in this video, we're just going to talk about how we convert from from infix into postfix. And we do that also using stacks. Okay, so we're going to start with just converting this really simple expression 4 plus 3, and then we'll move on to evaluating this more extremely complex infix expression. Again, the goal is to convert from infix into postfix. To do that, we'll use two stacks, an op stack and a postfix stack. So the op stack is going to kind of keep track of our operators as we go, and the postfix stack is actually where we're going to generate the postfix expression. So this stack will hold our answer at the end of the algorithm. Now I've represented these stacks horizontally just because they're too long for the screen to be vertical. So the bottom here is on the left and the top is on the right. Now when we're evaluating postfix expression, we do need to think about those rules of precedence. So remember that in Java as well as in mathematics, division and multiplication have precedence that's equal to each other. And that precedence is higher than the precedence for addition and subtraction, which is also equal to each other. So you've got multiplication and division are equal to each other but higher. Addition and subtraction are equal to each other but lower precedence than that. Okay? Now in Java as well as again in mathematics, parentheses have kind of your highest level of precedence. Now it's going to be a little bit different how we're going to treat parentheses in this algorithm, and I'll talk about that when we get to it. So let's again just start with a really simple 4 plus 3. So the general rule for if you have a variable or a number is you just push it directly onto the postfix stack. So pretty easy, we just put our 4 right there. Next up is our operator, the plus sign. So when we're evaluating our operator, what we do for operators is we compare them to what's in the op stack. But the op stack right now is empty, so all we do is just push that operator onto the op stack. And then next up is our 3. That's a value, so we just push it onto postfix. And then we've reached the end of our expression, and the rule for that is you just pop everything off the op stack and push it onto the postfix stack. And now if we read our postfix expression from bottom to top, we will get our if we read our postfix stack from bottom to top, we'll get our postfix expression. So if 4 plus 3 is the infix, 3 plus is the postfix. These are the equivalent infix and postfix expressions. So again, in the next video, we'll see how we can use a stack to actually evaluate something like this. But right now, all we're trying to do is convert from this to that. Okay, so let's trace through the full algorithm using our more complex expressions so we can take a look at all the different rules that we'll need to know. Okay, so first up we start with just a 4. 4 is just a value, so we just take that value and we push it onto postfix. Next up is an operator, the multiplication. So for operators, we do need to compare it to what's currently on the op stack, but for our case right now, again, the op stack is empty, so when that's the case, we just push that operator onto the op stack. Next up is a left parenthesis. So for left parentheses, the rule is you just push it onto the op stack. So again, in this algorithm, parentheses are treated differently from our traditional mathematical operators. Okay, next up we've got a 2. 2 is a value, so we just push it right onto postfix. Then we've got a multiplication sign. For any operator, we need to compare it to what's already on the op stack. But if what's on the top of the op stack is a left parens, we just ignore it and we just push this right on. Okay, so next up is a 3. 3 is a value, so we just push it onto postfix. Next up is an addition sign. So this is an operator. So now again, for operators, we need to compare to what's on top of the op stack. But if what's on top of there is an actual mathematical operator, then we need to do some work. So the general rule is that if the operator on top of the op stack has greater than or equal to precedence to the operator you're currently evaluating, you pop it off the op stack and push it onto postfix. So that's true, right? Multiplication has higher precedence than addition, so we need to take it off the op stack and push it onto the postfix. And we repeat that process as long as there's a mathematical operator on the top of the op stack. Now when we look back at the op stack, we have a left paren, so we're done. So now we just take this plus sign and we push it onto the op stack. Okay, next up is the value 3. 3 is again a value, so it just gets pushed onto postfix. Next up is a plus sign. Plus sign is an operator, so we need to compare it with what's already on the top of our op stack. So what's on the top of our op stack is a plus sign. Plus sign does have greater than or equal to precedence, right? In this case, it has an equal to precedence. So we pop it off op stack, push it onto postfix. Then looking at the top of the op stack, it's that left parens, which I can just ignore. So I just take my plus sign and I push it onto the op stack. Okay, next up is my 6. 6 is a value, so I just push it onto postfix. Next up is division. So division is an operator, so I need to compare it with what's already on the op stack. So when I look at my op stack, the top of the op stack is a mathematical operator, but it has a lower precedence than what I'm currently looking at, right? Division is higher, addition is lower, so it doesn't meet that rule of having to pop and push onto postfix, so I just leave it where it is, and I then push my division operator onto op stack. Okay. Next up, we've got another left parens. Remember the rule for left parens is we just push it onto the op stack. Then we've got a value 2. So 2, we just push onto the postfix. Then we've got an operator plus sign. So I want to compare my operator with what's on the top of the stack, the top of the op stack, but the top of the op stack is just a left paren, so I kind of just ignore it. I push my plus onto the op stack. Next up, I've got my value of a 1. Values just get pushed directly onto postfix. Then I've got a right paren. So this is the first time we've seen a right paren. So the rule for a right paren, the right parens never actually get pushed onto the stack. All we do when we hit a right paren is we pop things off the op stack till we meet the matching left paren. So here we're going to pop off the plus sign and push it onto postfix. Okay, and then we'd go back here, and because the next symbol is the left paren, that's kind of the matching one, so we just pop it and we're done with it. So we're done with that left paren, and we're also done with the right paren. Okay. Next up, I've got a plus sign. So this is what I'm evaluating, my operator. So I'm going to take a look at that. So now same rules apply. I have to compare to what's on top of the op stack. Right now, what's on top of the op stack has a higher precedence. So I pop it off op stack, push it onto postfix. I keep going. I look at what's on top of op stack. Right now, what's on top of op stack has a higher or equal to precedence, in this case equal to. So I pop it off op stack, push it onto postfix, and then I hit my left paren, so I'm done kind of evaluating, and I just go ahead and push that plus sign on. Then I've got the 2. 2 is a value, so I just push it right to postfix. Then I've got a closed paren. For a closed paren, remember what I do is I just pop off of the op stack and push onto the postfix until I meet the matching paren. So in this case, I just pop the plus off of the op stack onto the postfix stack, and then the next top is my left paren. So that's kind of my matching paren, which means I'm done with that. I'm done with this. Next up is my minus sign. So this is an operator, so same rules apply. I compare it to what's on the top of the op stack. Well, the top of the op stack is a higher precedence, so I pop it off op stack, push it onto postfix stack, and then my stack is empty, so now I just go ahead and push the subtraction sign onto the op stack. Then I've got my last token, which is the value 1. So I just push that onto Postfix, almost out of room. And now I've reached the end of my expression. So when we reach the end of the expression, the rule is we just pop off whatever is left on OpStack, push it onto Postfix, and we're done. And now our Postfix expression would be the expression we get when we read from bottom to top. So that would be 423 times 3 plus 621 plus divided by plus 2 plus times 1 minus. That would be our Postfix expression. Okay, so that would look like this. 423 times 3 plus 621 plus minus plus 2 plus times 1 minus. That is our Postfix version of this Infix expression. Okay? So again, the general rules are if it's a value, just push it onto Postfix. If it's a left paren, just push it onto OpStack. If it's an operator, you have to compare to what's ever on the OpStack, and as long as what's on the OpStack has greater than or equal to precedence, you pop that operator from OpStack, push it onto Postfix, and you keep doing that until either you empty the OpStack or you reach a left parens, and then you stop, and you just push the current operator onto OpStack. The other rule, if you hit a right parens, you just pop off the OpStack until you reach the matching left parens. And then again, your Postfix stack read from bottom to top will be your Postfix expression. And in the next video, we'll look at how we can use stacks to actually evaluate this Postfix expression.